So now we're going to take a deep dive into the code that makes all of this work, and we'll go through it step by step so that you can see how all this is wired together.
And we'll do that by literally just debugging through the whole process so you can see how all the code links up.
Now, if you have the Pro version of your subscription, you'll be able to get access to the full source code, which we hope you'll be able to quickly get up and running yourself. But even if you don't, we're going to show you all the moving parts so that this will be valuable for you in your own applications if you need to do something similar.
We're back in the Vet Manager, and the user is on the phone with Steve, who wants to make an appointment with Darwin. Everything works just the same way it's worked before. We'll go ahead and add a new appointment and save the appointment, which triggers the schedule aggregate routes add new appointment method. We haven't changed anything in the method. The only thing that's different is that now we've got an additional subscriber that's listening for this domain event, this particular domain event, the appointment scheduled event, to be raised. So we'll go ahead and raise the event and watch what happens.
Now, at this point, we're looking at a new class that we created, which is this Relay Appointment Scheduled service. And what it's responsible for is creating the event that is going to get pushed onto the message bus for the notification application, which is our public website.
This is the new piece of logic that's listening for the event that we just raised.
You can see it's implementing iHandle appointment scheduled event. And in the method, the first thing we do is we get this appointment DTO. And this DTO is a data transfer object. And the reason why we need appointment DTO instead of just appointment is because we're going to actually send this data in a message outside of our application. And outside of this aggregate route and outside of our application, other applications don't care about things like the doctor ID and the patient ID. They want to be able to create an email to send, and they want to know things like the doctor's name and the client's name and things like that, not the IDs.
So instead of using the appointment type that the scheduling domain uses, we've got this DTO, which has its own class definition. It's got the ID that we know about, but then the rest of these fields are everything we would need to construct an email with.
Now we're going to take that and put it into an application event. We've given it the same name. It's the appointment scheduled event. But notice the namespace is different. This is in the application events namespace. And so it's slightly different than the one that we publish within our application. The main difference here is that it takes this DTO type instead of taking in the appointment entity type that's part of our aggregate route.
In our application, we're using these application events in a similar way as we use domain events, except we're raising the events from our application to listeners that are external from our application. This is also an important pattern for communicating between one or more bounded contexts in your system.
So now in the publish method that lives inside of a service broker message publisher, which is inside of an infrastructure project. So this is in our data project. It's not inside of our core domain any longer.
But it is still in the main scheduling application.
Yes. And what it's responsible for doing is actually getting that message into a structure, a format that our SQL Service Broker can understand. And so it's doing some low-level work here, talking to SQL Server, putting things into JSON format in this case, and then actually sending the message. So once this thing fires, we should be able to inspect the message queue in SQL Server and verify that our message has actually been queued up on the notifier queue as expected.
And that's what we did before, but this time we're actually seeing the code that's making all of this happen.
All right, so that completes the actual thread of the UI.
So now looking at the notifier queue in SQL Server Service Broker, we can see the new message sitting there.
Now we're going to pause this and switch to the other application.
So here we are in the web app. We've just started it up again, and we showed this to you before. Now we're going to watch the flow of the code after start checking messages is called.
Right, so we didn't actually look at any of the detail of how we're doing that timer, So if you're interested in that, it's just these couple of methods here that creates a thread on this start job method. It's running right here, and it very simply sets up a timer to check every 5 seconds to see if there's anything new coming from the message queue. And in this case, it only checks for one message every 5 seconds, so it would be possible to flood our system. But given that they're only doing, a couple of dozen appointments per day, we don't expect that that'll be an issue for this system. And we could always tweak the timing. Jumping to the next breakpoint, you can see now we're inside of the actual check messages method, and it uses a lot of similar plumbing code to talk to SQL Server. We're using this service broker wrapper to help a little bit with pulling out these messages. And then it needs to deserialize the object that it's getting from JSON back into an appointment scheduled event. In this case, we've defined a copy of the same class inside of our public website. Alternately, we could have had these shared classes in a common assembly that was distributed to both applications. Either one would work. JSON will deserialize it as long as they match. And then immediately inside of this method, we're going to send this confirmation email. We get this email sender from StructureMap, and it implements the iSend confirmation email interface. And then we call the method on this particular implementation to send the confirmation email.
And the code behind send confirmation email is just completely standard SMTP code to send an email out. So nothing special happening there. I just wanted to remind you that critical piece of that email is the hyperlink that we build using the appointment ID, and then it just gets sent out.
Right, and that's the whole reason why this needs to be in the public website and not in our scheduler application, is because our scheduler is just sitting inside the local network at the vet clinic, and the customer needs to be able to click on this link to communicate back.
Okay, and so that's it for now for the public website. So the next step in the workflow is triggered when the user clicks on that link in the email. And now we're back to the website where the confirm method has been triggered.
Right, and in the confirm method, it's just going to call something to send that message back now from the public website to the scheduler's queue, which is a separate queue.
The definition of that message in this case is really just going to be a message that contains the appointment ID of the appointment that's just been confirmed.
Right, if we look at this event, you can see it's very simple. It's got just the appointment ID and some other information that's not related to the event itself. So we can see the same kind of code here that's connecting to our SQL database in order to post this message to the queue. And in this case, it's posting it from the notifier service to the scheduler service, which means that this message will show up in the scheduler's queue once this code executes. Now we should be able to check to see that the scheduler queue has the new message, and you can see that it does. So once we stop pausing this application, we'll see the next step in the workflow. Now remember, we're back inside of our main scheduling application where it is running a similar timer-based thing to check the queue. In this case, it's checking the scheduler queue, and it just picked up that appointment confirmed event that was in that message, translated it back from JSON, and is raising it within our domain.
This is really the last piece of the puzzle where the handler for that event retrieves the appointment for that particular schedule, calls the confirm method on appointment, which will change that value, and then uses the repository to update back to the database.
It's worth noting in this case that the appointment confirmed event that we are handling in this email confirmation handler is the application event appointment confirmed event. When we actually confirm the appointment using its confirm method, remember that it's going to raise a domain event that we handle separately in the user interface. So once we continue running, now we're inside of the appointment and we've just confirmed it. And this is going to raise now an appointment confirmed event that is part of our domain. Once we raise this event, the UI is going to pick it up.
That's because we already have the plumbing in place for the UI to listen for changes to appointment properties.
Now we're back inside the website, and this is in our hubs folder, so this is using ASP.NET SignalR. It's going to finally raise this confirmation information and show the alert in the browser.
So this is a new handler, but the logic inside of the handler is not new. We've been using that same logic all along with the appointment update handler that triggers changes to the UI.
Right, so then finally once this runs, if we jump back to the browser, we'll see the notification and we'll see that my appointment now has a green border. The last couple things we wanted to show about this user interface that we got for free are the ability to see the whole work week, and it's a little bit tight here in this resolution, but you can see all the different scheduled items and they're still formatted with the green boxes to show that they're confirmed. Or you can just look at the agenda for each room, and so each doctor could see, here's who they have on their agenda for today, and they could print this out.
And that's not anything we've written. That's actually part of the control that we're using.
Yeah, exactly.